Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and for the last little over a week, I've been doing a new feature on this channel. Namely, I'm going through the Math Lovers book. This is a 3-volume series I wrote from 2019 to 2022. The first volume, let's give a little overview again. First volume is recreational math. High school level. Second volume is more academic math and a little more advanced undergraduate level. And the third volume is problems and solutions pertaining to the first two volumes. You can watch some of my other videos if you want to know more details. But I'm doing a series of, lecture series on the Math Lovers book, at least the first two volumes. And I'm up to chapter 2 of the first volume now. I finished chapter 1 after about a week. This is my second video on chapter 2, which is about natural numbers. And in section 1 still, I did one video already on section 2.1, which is on figurate numbers. Figurate numbers are numbers that can be represented by a geometric figure, like a square or a cube. So yesterday I did a video where I was just talking about powers, which are like squares, cubes, or higher dimensional analogs, which I'm sure you guys are all familiar with. And those are very easy to compute. You just multiply the number you start with by the exponent, or the power, if you like. Anyway, today I'm going to talk about some more interesting figurate numbers. I think they're more interesting, but they're also very useful. So I'm going to talk about triangles, or triangular numbers, I guess they're more commonly called, and hexes, which are numbers inside where you have a hexagonal array. So anyway, let's begin. So I'm going to start with triangular numbers, and you probably learned this in grade school too. I mean, if you have an equilateral triangle, you can fill it with various shapes. Here I did it with circles, and you see that you got one circle on the first row, two on the second row, three on the third row, four on the fourth row, so on. This we would write as T4, the fourth triangular number, because it's the number of objects in a triangle. It doesn't have to be equilateral, by the way. I usually draw it like that. But when you have a triangle whose sides are length 4, you want to know how many objects you have in that triangular array. And coming up with a formula for this is more complicated than for a square. For a square, which is a special type of rectangle, you just multiply the length by the width. But you can't do that for a triangle. So what can you do? Well, you can do a little trick. I'll show you how this trick works. So the first thing you do is you rearrange these objects, circles in this case, slightly. You change it from an equilateral triangle to a right triangle. And that's pretty easy to do. You just slide the circles in each row over to the left. So now you've got, one circle on the far left in the top row, and then the second row you've got a circle on the far left, and then a circle to the right next to it, so on, all the way down to the last row. And how does that help us? Well, you'll see in a second. So the trick here's the trick. This is where this is kind of nice. What happens if you take a mirror image of this original triangle? So now we've got white circles and black circles. And our original triangle had the white circles, or discs, if you like. People usually say disk for solid circle. Technically in math, a circle is really just the boundary. It's a one-dimensional object. It's just the perimeter of the circle. If you want to talk about the whole circle, we usually call them as disks. Just to let you guys know what mathematicians prefer. So we've got these white disks and black disks, and I think you can see that they're basically the same picture, except that the black disks are upside down and shifted. I mean, you can see it's another 4 by 4 right triangle of circles. So now we've just added twice. So if we called the original number of circles T4, and it's easy to count these, by the way. I mean, it should be no surprise for you guys to know that T4 is 10, because it's easy to count these 10 triangles. Also, like 10 bowling pins. I'm sure most of you guys have been bowling. So this is the same array you get when you're bowling. This is how the pins look. So I think you guys all knew this was 10 right away. But pretend you didn't know this. So we're trying to determine how many of these pins are. So we rearrange them into a right triangle, and then we make an identical right triangle except reflect it and shift it over and rotate 180 degrees, I should say. But so now we've got 20. I mean, we've got 2T4 if you like. So 2T4, and now we have a rectangle. And this is nice because now we know how to compute how many objects there are in a rectangle. Its length is 5 and its width is 4. So 5 times 4 is 20. That means that 2T4 is 20, so T4 is 10. And the nice thing about this is it'll work for any size triangle. It doesn't have to be 4. So Tn. And you can do the same trick. 2Tn, in the case where n is an arbitrary length of your original triangle, 2Tn is going to give you n times n plus 1. I mean, you're going to have a right triangle on the lower left with n in this case, and then you have an identical one right next to it, but then your length is n plus 1 because you had one circle from the original triangle on the top row, but then you've got your n black circles next to it, so that's n plus 1. So we determine that 2Tn equals n times n plus 1. To get Tn, all you have to do is divide by 2. So therefore Tn equals n 1 half times n. 1 half n times n plus 1. Sometimes people write this as n times n plus 1 over 2. Anyway, that's the formula. That's how you come up with a formula for the nth triangular number. And this is a useful formula because, like I said, the nth triangular number is the sum of all the numbers from 1 to n. And I think that's easy to see because if you have a triangle, let's just look at this triangle again. I already was kind of alluding to this. If the first row has 1 object, the second row has 2 objects, third row has 3 objects, all the way up to the nth row, which is going to have n objects. So you can see the total number of objects is 1 plus 2 plus 3 and so on all the way up to n. So the sum of all the numbers up to n is the nth triangular number, and we have a formula for now. 1 half n times n plus 1. Pretty nice. And that's just triangular numbers. And what about hexes? So hexes are a little more complicated. And here's an example. This is what we would call H4. So a hex, the way I'm defining a hex, and they're not called hexagonal numbers, by the way, because that means something a little bit different. But hexes are like this. So I think you can kind of see how these hexes work. You have a regular hexagon in this case, but there's 4 objects on each edge of the hexagon, and then it's completely filled in this nice triangular array. And we want to know how many objects there are in this hexagon and this hex. That's what we call H4, the 4th hex. Well, you could just count them all, but they get hard to count. I mean, I'll just tell you the number. It might not be obvious how many what H4 is. It turns out to equal 37. If you counted all these circles, you'd find there's 37 circles. But how can you get this without counting? It's not so obvious. Well, there's another trick we can use. We can do this. So here I've colored the circles in each of the colors of the rainbow: red, orange, yellow, green, blue, and violet. I call it purple here. I don't even know the difference between purple and violet. I've always thought they were the same color. Maybe you guys can tell me different. I don't know. I've also heard that purple is a mixture of red and blue. Those are what are called subtractive primary colors. I don't want to get into theory of colors, but yeah. Anyway, enough of that. So in my book I call them red, orange, yellow, green, blue, and purple, but you can call them violet if you like. But anyway, here's what you should notice here. Notice that each of the objects of a given color is a triangle, right? We've got a red triangle, an orange triangle, yellow triangle, green triangle, blue triangle, and violet triangle. Each of those triangles has a side of length 3. So we had to subtract 1 from the original side. That's what's a little bit tricky. But we can write this down. It's 6Tn minus 1. So Hn is 6 times Tn minus 1. But then don't forget there's also another circle in the middle that's not colored. So you have to add 1 when you're done. So that's how you get a formula for for the hn. Hn is 6 times Tn minus 1 plus 1. We can actually simplify it a little bit. Now you have to do a little bit of algebra. But in the case where H4, it's just it's 6. You can see that the triangles each have 6. So if you wanted to shortcut your counting, just notice that each of these colored triangles has 6 circles, so, or 6 discs if you like. So 6 times 6 is 36, but then there's one in the middle that makes 37. So that's how you show that H4 is equal to 37 without counting them all. But there's nothing special about 4. We could have done this for any side length. And like I was saying before, I think I kind of jumped the gun here, but here's the formula on the second formula on the slide. It says Hn is 6Tn minus 1 plus 1. That's just what I said. And now we have a formula for Tn, so we can plug that one in. And remember, Tn was equal to 1/2 times n plus 1. Well, now we're doing Tn minus 1, so we have to substitute n minus 1 for n. And 1/2 multiplied by 6 gives you 3. So now you've got 3 times, in place of n we write n minus 1. In place of n plus 1 we write n. And then we have to add 1 at the end. And when you do this algebra, I'm not going to show all the steps here. You can do it yourself. You get 3n squared minus 3n plus 1. That's the formula for the nth hex. Pretty nice formula. And I only did it for H4, but you can do it for any H you want. Maybe I should give you an example just before I end this lecture. So what about when n is 10? Well, that's pretty easy. So we have 3 times 10 squared. 10 squared is 100. So you get 300. And now you're subtracting 3 times 10. That's 30. So 300 minus 30 is 270. And then you add 1. So you get 271. That means if you had a hex whose side length was 10, and in that case it would be really hard to count them all. You'd be counting for a long time. But you could just apply this formula and see there's going to be 271 in that case. So that's how that works. Pretty nice. Anyway, that concludes my lesson for today on triangular numbers and hexes. Thank you for watching. Long live math, and I'll see you guys next time. Bye.